The broadcast is now starting. All attendees are in listen-only mode.
All right, welcome everyone to today's MEP project process part 2. And if you don't already know or haven't already signed up for it, we have Midwest U coming up at the end of the month. And I encourage you to attend. There's a lot of really good information, a lot of good sessions. And my name is John Atkinson. I'm an applications engineer at CAD Technology Center. And with that, I'll start. I'm just going to kind of go over what a little bit of what we covered last time. We focused on HVAC and how to get information in and out of our project. And it's really important to the success of a project to have a defined workflow. And that includes having good template, good content, and some established standards. Then once we've brought in our architectural model and linked it, we do our levels and grids, we define our spaces, we create our zones, and then we export that to Train Trace 700, get our load calculations, bring them back in, and then using a schedule, we define the airflows for each of those rooms. And if you haven't seen the previous webinar, I encourage you to go to our YouTube channel and take a quick look at it. So once we we have our grills, diffusers, registers all in place, we define our airflows, we add our mechanical equipment, create our logical systems, and then start combining those systems, choosing the mechanical equipment, and we can do the same thing for our VAVs, combining those and attaching those to the air handling unit to get all of that data moving. We created a zone and space schedule and embedded an air terminal schedule. We adjusted the air terminal flow based upon the loads we got from Trace. And then we generated our ductwork layout. We used tab to select the entire system and used our duct and pipe sizing tool to define those sizes and let Revit do all that work for us. And now we move on to the hydronic portion. So in the previous example, we had our VAVs automatically calculating our GPM based upon CFM and the BTUs, what type of hydronic system was it? Was it water only? Glycol, what percentage of glycol? And then we place our equipment. In this case, we're going to use a boiler, and then we create all the systems for that. So quick example, I have my VAVs here, and if we scroll down, you'll see I've got my heating coil entering and leaving temperatures, and I also have my CFM and my air leaving and entering temperatures. So this particular case at 1500 CFM, I'm going to need 1.5 GPM. Now on this particular VAV, I don't have it hooked up to anything right now, but I've defined it as 600 CFM, and that's going to give me 0.6 GPM. And then on this one down here, again, I don't have it hooked up to anything, but I've defined it as 300 CFM. And I get a minimum flow of half a gallon. So I want to take these three units and these two over here, and I'm going to create a piping system. Now that piping system, I can either pick hot water supply or hot water return, and then any other number of different systems that I have available. I'll create that. And down here I've got a boiler, so I'm going to use select equipment. Now I can either pipe that up manually, or just as kind of a way to get started, I'll use generate layout. And you can see I've got these green lines and blue lines. The blue lines are my mains, the green lines are my branches. And I can come in here under settings and change my main. I can change the type of pipe that it's going to place and the elevation that it's going to go in at. Same with my branch. I can define the type and the elevation. Now I'll have, just like we saw in ductwork, I'll have several options that I can click through to sort of pick what's best for me in my situation. And if I get one that's close, but it's not quite exact, I can come into edit the layout, select one segment of it, and move that off to the side. Get this one to line up as well. I can move my branches out a little bit. And then I can say finish layout. And that's going to bring me back to the supply of the boiler. And as you can see on this unit, I've defined him as 1800 CFM, and he's this unit's looking for 1.7 GPM. And that will propagate through. As you can see, I've got a flow of 1.7 GPM coming through this pipe. And all of that is going to keep adding up as I get down to my unit here. Now, one of the things I can do now that I have that in place is I can hit tab and select the entire system and come up and hit my duct and pipe sizing, choose a velocity. Maybe I want 2.5 gallons or 2.5 feet per second, and say OK. And that's going to go through and resize everything. So we can see this is a 1/2 inch. That's my minimum. There's my flow. Here's 3/4 inch diameter with 3.2. So that's adding the 1.5 plus my 1.7. And as we get all the way back to our boiler, we'll see we're at 4.8 GPM. Now we can grab all these units again hit our piping tool, heating water return. We can name our system after our boiler. Say OK, select our equipment, and do another generate layout. And since I don't want these pipes going over the top of each other, I come into my settings and I can change this to 10'6" and the same for my branch. And again, we can come in here, edit our layout, just so that it's a little more legible. And I'm going to adjust this one. Okay. And finish that layout. You can see this return is getting the same amount of flow as our supply. And we'll run the pipe sizing tool on it again. Now, one of the key things to getting all this data moving through our model is going to be connectors. So if I take a look at this boiler, I can see I've got my condensate drainage. Here's my return connector. Here's my hydronic supply connector. Then I have gas in and exhaust out. So with the supply, it's important that the flow configuration is calculated so that it's looking at what's connected to the system. And that will then populate our heating coil water flow parameter. Then it's set to out. We've defined it. We've given it a name. And if we look at our return connector, that's going to be preset. And again, it's going to be looking at the heating coil flow. So this connector takes the information from the system, populates the parameter, and then pushes that information to this connector. So what we've done is we've placed our equipment. We created our systems for supply and return. And now if your family is set up for calculating GPM, as these are, be warned that this is not, we're using formulas that are pretty industry standard, but they're basic. They're not going to be the same as your selection software. So if you were to go to use the Titus Teams, for instance, the coil selection, it may not be exact, but this is a really good ballpark figure. So as you can see, we've got all of our delta T's defined. We have propylene glycol selected, so that's going to give us our density. We have a number of coils. We can bump that up to 2, and that's going to change our flow rate as well. But again, it's still pretty rudimentary, but it does get us close to sizing, say, an expansion tank and a boiler, what are we going to need for that? And now we can move on to plumbing. And for plumbing, I like to use a series of groups for my fixtures, so that I can define the connectors, the fixture units, the GPM. And one of the things to be careful of is only model the stub outs, because you don't want to over model your fixtures. You may have a very large plan, and the more fixtures you put in, if you have the toilet bowls modeled up, or if you have the entire lavatory modeled up, then your model is going to get pretty heavy pretty quickly. So I recommend just doing some stub out connectors and putting the information in those connectors. So what I'm going to do is I'm going to come down to my working views, go to my plumbing, change my work set, and you'll see here I have a group. I'll just do a quick copy and show you. Put that back up there. So within this group, I have my carrier, I've got some stub outs. These are my actual fixtures right here. I've got waste and domestic supply. I have my carrier unit, and then here I've got my main waste as well as a vent plumbed in. If we go into a 3D view, change that, and cancel that. Okay. I'm going to turn off my links in this view. Turn off HVAC and hydronic. And scope boxes. So here's my group. You can see it's pretty simple. Even if I were to bump it up to fine, all I have is the carrier unit and then the waste connections going out. I've got my domestic supply, my vent. So what we can do is, once we have these in place, we can just use a line. Here, move him. Cancel. Move him over. I can align my systems. And he's pretty much ready to go. Then what I'll do is I'll just copy him over to the next one, and over to the next one. And in order to make my connections, then I can just select all of them, ungroup them, come down into my section view, and just start making connections. I've got one here. I don't want any of that vent. Then it's just a matter of connecting things up. Same with the domestic water attachments. Get rid of that. Come And we can come under modify and use trim and extend multiple. And I got the wrong one. Hide that guy temporarily. And as you can see, it's pretty fast just attaching these elements. Now, getting on to our actual sanitary system, my personal recommendation is to not slope your pipe until near the very end of the project. One of the reasons being that if we do have this sloped, connecting into it isn't always the easiest thing. So I can slope that up, and now to drop this in, that one worked, but a lot of times Revit will fail, or it'll give us a backwards connection and something that just won't work. Now, one of the other things that you may come across is if I do put in a connection, it's going to give me a backwards T, and that's due to the direction that Revit perceives as the direction of flow, and that's based upon which direction you draw the pipe from. So I could come in here and just manually flip this, but if I have any further T's coming in, they're also going to be backwards. So one of the things I can do is just delete that, redrag it. Oh, I went the wrong way. Start from this end, go back, and that resets my direction of flow. So now anything that comes into it is going to have the proper direction of flow. And once we get all of that modeled up flat, then I can come in and use, let me go to my plan, use tab to select my pipe and then apply slope to the entire thing. And it's going to give me a slope control point here. And that slope control point is going to be the bottom of my system. So you can see if I were to stretch this out, it's going to go all the way back and drop into our main. So that's all there is to setting up a plumbing system and hydronics. Are there any other questions? No? All right. Thank you for watching. And please remember that Midwest U is coming up at the end of the month. If you haven't signed up, do so. Like I said, there's a lot of great topics and hope to see you there. Thank you.